All right, so last time we were starting to look at that standard normal distribution. Now keep in mind that key thing when we're talking about the standard normal distribution. It has the nice normal curve. It has the mean of 0 and a standard deviation of 1. So it's much more specific than just saying it is a normal curve. It is a normal curve where the mean is 0, standard deviation is 1. So it is a perfectly normal distribution, and having that mean being 0 is important within this. We will be looking on Wednesday at what to do when we don't have a mean of 0 or a standard deviation of 1, because I don't want to have to make new tables, new data each time. That formula that we looked at that was a complex formula to calculate things out. Now, when we're looking at that distribution, one of the key things that we have is the fact that the area under the curve, always make it way too high. There we go. The area under the curve is going to total 1. 100% of the values are going to be underneath there. The area under the curve is connected to the probability. So that as you're trying to figure out the area under this curve, it's going to tell you what the probability is. And so we'll be using the z-scores. Remember we talked about z-scores back in chapter 3. Z-scores are just telling me how many standard deviations. Positive z-score means you're above the mean, and negative z-score means you're below the mean. It's just telling you how far away from that mean you're at. And the formula we used for the z-score was the x value you had minus the mean divided by the standard deviation. And that was if it was for a population. If it was for a sample, same concept of trying to find where your z-score is to be able to compare how you are in comparison to the rest of that population. When we were looking at things last time, we were using the tables to help us try to figure out what was those different probabilities. I want you guys to go ahead and use your tables to refresh your memories on what you were doing on this problem. If I am trying to find the probability that my z-score is between negative 0.56 and 1.78. Table A2. And did you have your test corrections? Or did you do test corrections? Oh, that's right. You guys were missing last time. Want that back unless you've got blue slips. Shelby, did you see yours yet? I'll want it back since you don't have the blue slips. Okay, a couple of the things to remember that I mentioned to you guys last time. Were you done looking at it? First of all, you do have on your table two different sides. You've got your positive z-scores and your negative z-scores. And so you have to figure out which one of the two tables that you're looking at. Also, a key thing that it does talk about on this is that your probabilities, that the values inside the body of our text is always the cumulative area from the left. And remember that's always coming from the left is extremely important on these as you're doing them. So if I'm trying to find the probability that my value is between negative 0.56 and 1.78. What you're going to end up finding is probability that's less than the 1.78, so that's going to be right about there. So that's going to be the area to the left is what you're going to find on this. But we want it to be more than that negative 0.56. But it's going to give me my area to the left over here. What I want to find is just this area that's between. So you have to subtract those values off. So you're going to find the probability that your z is less than the 1.78 minus the probability that your z is less than the negative 0.56. First of all, I find the probability that z is less than the 1.78. As you're reading your table, are we using the negative or the positive side? The negative 0.78 will be using the positive side. When you're reading that, it takes a lot of information to be able to get to that right spot. Because you've got that 1.78. Your z-scores are along this left column and across the top. It takes both parts to figure out where you're at. The 1.78, 7, across the top tells me my hundredths place. We come over here to the 0.08, and we find that one spot where those two things meet. The probability that's less than the 1.78 is your 0.9625. Questions finding that? So that is telling me that the probability that I will have is a value, z-score being less than the 1.78 is going to be 0.9625, but that keeps going to the left forever. We're wanting it to stop here at the negative 0.56. So if I'm wanting the probability that it's less than the negative 0.56, now we're looking at the negative z-score table. We come down to the negative 0.5. So the negative 0.5 is down here towards the bottom. Going across the top, 0.06. Finding that spot to be the 0.2877. Everybody finding that okay? Reading these tables is going to be a huge thing we're going to use a lot this chapter and next chapter. So make sure you're understanding these tables because I know a few of you guys are gone Friday. So it's giving you your z-score goes across the top, across the side, and across the top to find one part for your z-score. The stuff in the body is your area, which is equivalent to our probabilities. So that's that 0.2877. I'm finding the probability that's between. Track those, and those of you with calculators, what do you get? 0.67 what? So the probability that I'm going to get a z-score that's between 0.56 and 0.78 is a 0.6748, so 67.5% chance. As we're doing these, we will always round these to 4 decimals. Not a whole lot of reasoning why, other than the fact that's where the tables round them to. So even as we use our calculators, we'll just round them to 4 decimals. Questions there? So since I found it, what do you mean by between the two? I don't mean that. But if you said that, it doesn't make sense to say greater than and less than, because without you don't have anything that makes sense. Now, what you could be, and I think what you're trying to say, if I said the less than the negative 0.5, I put my decimals in the wrong spot, less than the negative 0.56 or greater than that might be one thing you might read. I think the part you're really thinking of is if I asked what is the probability that z is greater than, let's go with 0.81. I think that's the one you're actually thinking of. If I wanted to find the probability that z is greater than the 0.81, first of all, when I look at my table, what do we get? $7910, okay. But the problem with this one is I'm wanting the probability that it is greater than this. What you just found, and I already lost the numbers, was 0.7 what? Okay. We just found the probability that it's less than that. How do you find the probability that it's greater than? Subtract that from 1. Take the 1 minus 0.7910. And whatever that is. No, 209. Questions there? So when you're trying to find, when you're looking for figuring out what's greater than, you have to remember that it always tells me my probability that it's less than. It's wise to draw pictures. I highly recommend, even as you start using your calculators to help you figure out your answers on these, to draw yourselves a picture. I don't expect, if you haven't noticed, I don't draw great normal distributions each time, and so I'm not expecting great pictures, but just to have a little something there to help you figure out which area am I even looking for. Am I looking for the stuff in between? Am I looking for the stuff to the left, or am I looking for the stuff to the right of it? As you're drawing these, you should recognize your zero is in the middle, and so you're looking for your z-scores either to the right or left as you're graphing that part of things. At least have it in somewhat of a general direction, but it doesn't have to be just amazingly great pictures as you're doing it. Just something to kind of help you think through what you're doing. Questions? Now, our calculators can help us. If I am wanting to try to find the area between two things, then we can use normal CBF is what I want to go to. So you're going to go back up to your distribution, which is your second in VARs, and we're going to do the second one down, which is the normal cumulative distribution. Normal cumulative distribution function. As you put that in, you're going to put your left z-score, then your right z-score. Lower first, upper second. And as you hit enter, we should get the same answer we had a second ago, which was the 0.6748. It will. So if we do the normal distribution, putting in your leftmost value, which is the negative 0.56, your rightmost value, which was the 1.78, and it's going to give us the 0.674722, and it keeps going. So you're going to round that to your 4 decimals. So the 0.674, a little bit of rounding error, 0.6748. So it's going to be 0.6747. This is definitely one of those problems, or definitely one of those areas. The book gives you both answers a lot of times. The book will give you answers according to the table, and the book will give you answers according to technology. And that way, depending upon which one of the two you use, you can check your answer, because there will be a lot of rounding errors on these. The tables have already had it rounded to the nearest 4 decimals. And so as you're doing these, they are not going to mean exactly 4 decimal places. So the calculator is more accurate. The calculator's answer being 0.67472 is actually a better answer. But if you've got the tables, you use what you've got. I do want you guys to be familiar with how to use the tables. So don't just completely do a few problems where you use the tables to do things. Also, I'd recommend being familiar with the calculator. So able to use both of those things is going to be useful. Questions? Now, the problem with the calculator, it only gives me the area between two things. What if I want to do the one on the bottom, the probability that z is less than 1.98? It would be easiest just to look it up. So I'm going to use that normal cumulative distribution from the left. So it's always going to give me my area to the left. What do you think we would want to put as our leftmost bound? If we're thinking about this, back to having my normal distribution, we're doing 1.98. So 1.98 is probably about right here. I'm wanting the area to the left. I need a leftmost bound. How far to the left can it go? Can it be negative? Let me ask that question. I'm seeing both answers. I'm hearing no and seeing yes. Can your z-scores be negative? Oh, don't let her change your answer. Z-scores can be negative. What's a negative z-score mean? Okay, it's the left to 0. It's smaller than your mean. So negative z-scores are possible. That negative z-scores just means your value is smaller than the mean. So I need a leftmost amount. Negative 3.5 is good, but it's possible that you can actually have something by chance to get negative 3.5. When you're talking about z-scores, we're saying usually things are between negative 2 and 2, but negative 3 to 3 happens about 99% of the time, and all these different things. Pick a leftmost value that's so extreme it's not likely to happen by chance, and it won't influence your data. So when we go to do this one, we're going to do a normal CDF. We are going to pick a negative value that's really negative, like 999, because that's not going to happen by chance. And then pick your rightmost value, which I wanted to be the 1.98. And it's going to give you pretty much the same thing as the table. Hopefully it does give you the exact same thing as the table. Now, as Sarah pointed out, it's easier just to look at the table and get the 0.9761, and you're done with it quickly, which is why being familiar with the tables is good. Whoever has the bird chirping, whatever, turn it off. So we still get that 0.9761 that we had before. And that's the same thing that the tables are giving you as you're doing things. Questions on that one? Well, no, negative 1 million would not. But if you had put like -1 or something like that where it's possible to happen, that changes because now you're cutting off some that actually happened by chance. And so that's the reason why we're picking something that's really extreme. Is -5 still giving you the same thing? No, it changes it a little? That's because I figured it probably would. So you want to go out to where it's, I mean, if you did -99, you're still going to get the same thing. But you're just trying to find something that's not going to happen by chance that it's at, as you're doing it, because that's what you're looking for. Questions on that? Now, this is given the z-score and trying to find the probabilities that those happen. We also want to go the other direction sometimes. Sometimes what we're looking for is, you know the probability, and I want to know what's the z-score that would be my cutoff values. So if I'm trying to find the z-score when you're given the probability, first thing you want to do is still draw your picture. So draw yourself a nice little bell-shaped curve. Identify the region under the curve that corresponds to the probability. If that region is not a cumulative region from the left, work instead with a known region that is a cumulative region from the left. So if I've given that I want to find the area that's more than, the top 5%, well, instead of thinking about the top 5%, I really should be looking for the lower 95%. and what would be the cutoff of separating that lower 95 from the top 5%, you want to look at your area to the left when you're doing these. After you have your picture, using the cumulative area from the left, locate the closest probability in the body of table A2 and identify the corresponding z-score. So you're working backwards. This time now, instead of knowing the z-score, you know the area. And so now what you're going to be doing is looking inside the body of our table A2 and trying to find what is the z-score that gives me that. So this is from the left, and so you have to start with the area from the left to figure out what area to the left you're looking for, then find the matching z-score. And make sure you read both the area, the z-score across the left and across the top to get it out to 2 decimals. So, looking for an example. Separating the bottom 95% from the top 5% happens a lot. If I want to know what is that z-score that separates that lower 95 from the top 5%, if I'm wanting to find the top 5%, the area to the left is 95%. So now I want to use my table and find the 0.95 in there. First question, do I use the positive or do I use the negative z-scores? Why positive? Okay, it's on the right side of 0. It's on the right side of my mean. I know this number, the 0.95, is bigger than 50%. 50% is smack dab in the middle. If I wanted to know what's the z-score that gives me 50% to the left, then that's 0, and I don't even have to look at the table. So if it's more than 50%, then you're on the right side, so you're using a positive z-score. If it's less than 50%, you're using a negative z-score. So on the positive thing, find the 0.95 in the body of the values. Well, if I'm trying to find the 0.95, I can find 0.9495, I can find 0.9505. In between is this asterisk. Top 5% used a lot. So in this case, if we follow the little arrow, it tells me down here at the bottom that a z-score of 1.645 gives me an area of 0.9500. So when you want to find the area to the left being 0.9500, our z-score is 1.645. Most of the time, you just want to find the value that's the closest. So you're going to do the best guess, not the best guess, the closest estimate to what you have. There's going to be a lot of areas you don't find exact values for. But you find the closest value to it. In this case, that 1.645 is a specific one because, like I said, you're going to use that one so much that it starts to become one that you have memorized. Not as much as a couple of the others, but there's a few of these that we see a lot when we get those memorized. So that z-score of 1.645 separates the lower 95% from the top 5%. So if you're trying to be in the top 5% of something, your standard deviation is 1.6 standard deviations above the mean. So if you're looking at having a, I know especially when you're in elementary school, the kids are constantly being given all these different tests, and then they put them of where their percentiles are and how they rank in comparison to things. So trying to look at where those comparisons are. To be in the top 95%, or sorry, to be in the top 5% means their standard deviation is 1.645 standard deviations above the mean. So notice our z-score is positive as we're finding that one. If, on the other hand, instead of just trying to find the top 5%, if I want to know, okay, where are those two extremes that give me 95% of the values in the middle, what's the cutoff of where you're the most extreme to be 5% on each one of those ends? So if I want to find the bottom 2.5% and the upper 2.5%. First of all, let's start simpler. If I want the bottom 2.5%. So notice I've drawn myself a picture. I want to find 95% in the middle. So this part here is my 95%. If I want 95% in the middle, I've got 5% on the two tails. It's going to be split in half, so 2.5% in the lower tail, 2.5% in the upper tail. If we start with the easier one, find the tail. What is that z-score that separates the bottom 2.5%? So first a question, am I looking on the positive or the negative z-scores? This time I'm on the negative because I'm definitely on the left side. Find 0.025 in the body of your text. Should be getting 1.96. Because as you're doing this, you're going to locate the 0.25 or 0.0250. Once you have that value, get where I can see everything I need. There we go. Once you get the value, you're going to go over here to the left to get the first part. So this is the negative 1.9. You're going to go to the top to get your second decimal, which is your 6. And so you're looking at negative 1.96. So a z-score of negative 1.96 separates that lower 2.5%. This is definitely a number you're going to start having memorized. Now, what if I wanted the upper tail? So this was your z-score of negative 1.96. So what were you saying? So we're doing the, no, 0.975. So we're doing the 0.975 is what you're going to look up in your body of your text. Are we looking on the negative or the positive? Positive. So if you look at the positive side, you're getting the 0.975. What are we getting? No. 1.96. Is everybody finding the 1.96? Should be getting the 1.96 this time. Now, this one has symmetry. If you have the standard normal distribution, then you know your mean is 0, and we have a standard deviation of 1. They're going to have that kind of symmetry, where the lower, if you have the same percent, that lower 2.5% and the upper 2.5% will have the same z-scores, just opposite signs. Now, as we start looking at things that are not your standard normal on Wednesday, that symmetry starts getting lost a little bit. It starts getting a little harder to find. Maybe I should word it that way. Symmetry starts getting a little harder to find, and so you're not going to have quite the same easiness of it as we go on beyond this. Questions there? Like I said, these two z-scores, the z-score for finding the top 5% or the z-scores for finding the 5% or 95% between are going to be two of these you're going to see a lot. So seeing this 1.96 and the 1.645 are two of them you're going to see a bunch of. Now, a lot of times we talk about the critical values. The expression z sub alpha denotes the z-score with an area of alpha to its right, where alpha is that Greek symbol that we'll be using. But z sub alpha tells me I'm looking for the z-score that has whatever that alpha value is, the area to the right. So your table tells you the area to the left. Alpha is telling you the area to the right. They're going in opposite directions, so you kind of have to be careful with what you're doing. So if I want to do number 44 on page 263, which just says find z sub alpha being, or z sub 0.02. So my alpha is 0.02. If I'm finding z of, that's telling me my area to the right is 0.02. Now, when you guys go to draw these, I don't expect you to have your z-scores across the bottom. I just keep using the same picture so it was easier for me. I want to have an area of 2% to the right. I'm not 100% sure where it's going to land. It's going to be somewhere close to this. So this would be what my picture would look like, is I just put a little normal distribution, and I'm coloring in that I want to have 2% to the right. Now, every time I'm doing this, I need to use my table. I need to find the area to the left. So what would be my area to the left? If it's 2% to the right, the area to the left is 98%. So the 0.98 is my area to the left. So the 1 minus the 0.02 is the 0.98 is the area to the left. Which one of those two values do I look up on my table? 0.98 or the 0.02? 0.98, because it's always the area to the left. So using my table, find the 0.98 in the body of my table, and find the z-score that goes with it. So what are you going with? No. No. 2.0 is getting closer. If we're looking at this, don't guess. The next digit is what I'm going to go with. So now we're looking for the 0.98. So 0.98 is between 0.798 and 0.9803. Oops, you can't see what I'm pointing, sorry. It's between the 0.9798 and the 0.9803. Which one is 0.98 closer to? Huh? Okay, yes, you're good with the number on the top. It's closer to 0.9798 because that's only off by 2 10,000ths versus 3 10,000ths. So since it's a little closer to this one, that's the one we're going to have to estimate with. So you will be using estimation if you're doing things in approximation, whichever one's closest. So it's closest to 0.9798. So if we go across, we've got the 2.0. If you go to the top, you have 0.05. So you're looking for 2.05 is your z-score. Remember, your z-scores are along the side and across the top. Your area, which is your probabilities, is in the inside. So 2.05 should be the value we're coming up with. So that z-score, which means I was really close with my estimation, because it should be that z is 2.05. My z-score that separates that bottom 98% from the top 2% is 2.05. So my z of 0.0, oh, I just wrote the wrong number. That should be 0.02. My z of 0.02 is the 2.05. There. Okay, let's look at number 50 on page 263. It's finding the temperature value. Exercises 49 to 52 assume the thermometer readings are normally distributed with a mean of 0 degrees Celsius and a standard deviation of 1 degree Celsius. A thermometer is randomly selected and tested. In each case, draw a sketch and find the temperature reading corresponding to the given information. So on these, they're trying to tell you that we do have a standard normal distribution because you have thermometers that you're testing. You're testing for the freezing point of water, which is 0 degrees Celsius. And so the mean is going to be that 0 degrees Celsius. They're off by one, possibly off by 1 standard deviation. So it is giving you a standard normal distribution. Most true data we're going to have will not come in as a nice, perfectly standard normal distribution. We're creating some that actually has a possibility of being there. So now what I'm looking for in number 50 is finding p sub 1, which is the first percentile. This is the temperature reading separating the bottom 1% from the top 99%. So we talked about percentiles back in chapter 1 or chapter 3. If I want p sub 1, that is the same thing as saying what? If I want first percentile, it's the same as saying z of what would be alpha, 0.01. They're both telling me my area to the right. So if I'm wanting to find what is it that separates the top 1% from the bottom 99%. So I'm wanting to have my area to the right of being 1%. I'm going to give you guys a moment to find that. Oh, wait a second. I'm sorry. I just read that backwards. That is the temperature reading separating the bottom 1%. I'm on the wrong side. I want the bottom 1%. I'm down here. So if it's the bottom 1%, it's not z of 0.01. It's z of, what's the area to the right? 0.99. Now, which one of those two numbers do I want to look up in my table, the 0.01 or the 0.99? The 0.01 is the area to the left. So this one's an easier one to not convert to the area to the right. So if you're looking up the 0.01, what do we come up with? As you get a much number in your boards if you've got your boards with you. This will be one of those chapters where you guys use your boards a lot. It'll be easy to have you give me a quick check. I like how you said 2. So you should be looking up the 0.01 in the area of our in the body of our text. If I'm looking at 0.01, we've got 0.0102, 0.0099, 0.0096. So it's right here between 0.012 and 0.0099. Which one of those is closer? Okay, 0.0099 is only off by 1/10,000th versus 2/10,000th. So we're looking at that 0.0099 as close as we can get with our table. What is that z-score? Okay, negative 2.3. If you're not seeing this, please do let me know, because you're going to get to use this table a lot. I will show you the calculator shortcuts, but a lot of times the table's faster and easier to use. So our z-score is the negative 2.33. Questions? All right, let's look at how the calculator can help you on this too. If you use the inverse normal, inverse means you're undoing, and so you're undoing the normal distribution. You're going to go to your second in vars, so you're going to your distributions. You're going to do that third one down, which is your inverse normal. You're going to put your area to the left. Just like on the tables, it's giving you your area to the left. You put this area to the area. So for that last problem, when I wanted the area to the left to be 1%, do inverse normal of 1%. You should be getting something close to negative 2.33, but it's not going to be exactly negative 2.33 because we had to round it. So you should be getting negative 2.32 something. We're still going to round it to 2 decimals. So just like, and the only reason is because you're going to do your z-score the same rounding as what we do if we use the table. So it still rounds to negative 2.33. There will be some of these problems, again, that the technology and the tables give you two different answers. Both answers, when they're different, both answers are given in the book. And so they'll give you one answer. The answer I think they give you first is with the tables, and then in parentheses they usually put tech, and then they put the answer that you would get with technology. I'll take both. So on the test, I have both answers on my test too. All right, I want you guys to find the z-score that separates the upper 2.5%. You better be getting a positive z-score. If you're not getting a positive z-score, you put something in your calculator wrong. We're doing inverse norm. It is the area to the left, 0.975, because the area to the right, and again, this is where I want you guys to just draw yourselves a quick, oh, that was a horrible picture, but drawing yourselves a quick little picture, and I'm saying I want the top 2.5%, which means the 1 minus the top 2.5%, so the 0.975 is the amount that I want inside here. And you should be getting 0.96 or something very close to it, aren't you? Questions that help you. Again, being familiar with the tables will be a useful thing to be able to do. So make sure you spend some time on this homework doing it with the tables, because you're going to need to be able to go back to use those, especially when it comes to the final and I get to throw everything at you at one time. Sometimes you forget which buttons to push to get the piece that you want. The tables will still be on that little piece of paper that I give you to be able to refer to, so you can go back and use the tables. Also, work on remembering what we do as we go along. Okay, thought I had one slide. All right, there's you guys' homework. Again, always as we've been doing things, try to read that next section ahead. We'll be doing section 6.3, which gets to work with the same kinds of stuff. It's just not standard normal distribution. Next time we get to look at it, and we have a mean that's not 0, but it's a deviation. So work on this homework, understanding it first. If you're going to graduate, hopefully you're with your advisor, because the application is due today. So make sure you have that application today. This test is going to be March 11th. Like I said, this next test comes. I guess it is next week, into next week.